All right, today we're going to talk about how do you find multiples of a number. Multiples is actually really easy. You've probably been doing it since second or third grade, but multiples is just like the word multiply because you're really taking your multiplication to find the multiples of a number. So for example, the first multiples you probably learned way back in first or second grade are the multiples of 2. And it's just skip counting. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on forever into infinity because numbers never stop. So those are multiples of 2. If I wanted to find multiples of 5, which is another set of multiples kids learn really quickly and young, well, we just skip count by 5. 5, 10, 15, 20, 25, 30, and so on forever and ever to infinity and beyond. Boop, boop, boop. So give this a try. Let's find some multiples of 4. So always the first multiple of any set of numbers is the number itself. 4 times 1. Then you're going to do 4 times 2, which is 8. 4 times 3, which is 12. 4 times 4, 16. Or you can just, skip count by that number if you know how. So 4 times 6, 4 times 7, 4 times 8, 4 times 9, 4 times 10, and so on forever. So give this a try, and why don't you try to find, let's say, some multiples of 6. Try it on your own, pause the video, and then let's check together. All right, hopefully you paused. 6, 12. Sometimes when I get stuck, I just think, okay, what's 6 times 1? 6 times 2, 6 times 3, 6 times 4. Or you can count up. I know I'm counting by 6, so 24, 25, 26, 27, 28, 29, 30. Well, I don't because, I know my times table, but if you get stuck. And you just keep going forever and ever and ever and ever and ever, forever, because infinity is the idea. It's not a number, but is the concept that numbers never stop because you can get the biggest number you can think of. You can always add one more. You can times that number by 2 and numbers will just keep going forever. And that's really it. That's multiples. But, let's not stop there. We are scholars. So something else to look for when you're looking at multiples are patterns. So if I'm looking at the multiples of 2, I notice there is a pattern. I have 2, 4, 6, 8, 0 in the ones place. 2, 4, 6, 8, 0 in the ones place. And that pattern does repeat forever. It's really, really neat. Same thing with if I'm looking for a pattern in the 5s, you might notice different patterns in the ones place or the 10 place. I look in the ones place a lot because that's where a lot of patterns will come up. But I see 5, 0, 5, 0, 5, 0, 5, 0. So there is a pattern that the ones place and multiples of 5 have to end in 0 or 5. So any number that ends with a 0 or 5 is a multiple of 5. That means I can divide by 5 and get no remainder. So let's see, is there a pattern with the 4s? That's something that you can look at and see, do you see a pattern? 4, 8, 2, 6, 4, 8. Oh, I think I do see one. I'm noticing 4, 8, 2, 6, 0. 4, 8, 2, 6, 0. That's interesting. I wonder if every number that ends with 2, 4, or 0, 4, 8, 2, 6, or 0 is a multiple of 4. I've actually never really explored that. That would be something cool to try a number that ends with those digits and see if it's divisible by 4 evenly. That could be interesting. So don't just do your multiples. See if you can find some cool patterns in there, and that helps your brain think a little more mathematically. But that's it. Multiples just means multiplying by a number and coming up, skip counting everything you've got from that number. So here's an interesting challenge is when you find a multiple of two different numbers. So let's say I'm giving a problem that says find a common multiple for, let's say, 2 and 6. So what I would do is I would list multiples of 2, list multiples of 6, and find one that is the same. So let's see, for 2, I can go 2, 4, 6, 8, 10, 12, and just, get a 5 or 6 out. For 6, 6, 12, 18, 24. Oh, I already see some common multiples. So 6 is a common multiple of 2 and 6, and so is 12. And I bet you there's even more if I were to keep going. So that's just kind of like a neat activity you can do with multiples, and it'll actually help you as you get older for more difficult math when you start doing fractions and ratios and things like that in higher grades. This skill will be really handy. So give it a try.